Alright guys, welcome to that ginormous graph stacking assignment. So we'll go ahead and get started on that here. I'll try to make this a pretty quick run through. So number one, we have a positive position and the position is not changing. If the position is not changing, that velocity is 0 the whole time. If the velocity is 0 the whole time, then our position time graph, we're just going to draw vertical dots. Number two, we see a constant linear velocity right here. So we've got a little bit of CLV working for us. And since that is a constant velocity, that means that on our velocity time graph, we can just go ahead and draw that. I will actually draw that slope correctly here. My apologies. That is a slope of 1. So that means that we have a constant linear velocity right there. We would define 0 and draw dots moving to the right, representing the positive velocity with the same size arrows. And number 3. Here we have a negative constant velocity, but still CLV. So this is negative, and this is negative. Our rise over run here, we are going down 4, and we are going over 5. So that would be negative 4/5, which is 0.8. So we're going to be just above that negative 1 line, but we're still constant. So here we'll define 0. We have a negative constant velocity. So these arrows will be the same direction and magnitude. Number 4, we have CLA. We've got constant linear acceleration here. And we know that because on the position time graph we're getting a curve. We're not getting a straight line, we're getting a curve. And this begins with smaller slopes that gradually increase, so that denotes an increase in the velocity. So our velocity will be changing. That's why we draw that line has a slope, because the slope of the velocity time graph is the acceleration. And now here will be more qualitative, but we're still starting at 0. Start with little arrows that get bigger and bigger to denote the acceleration. So moving on to number 5. Number 5, again, we're dealing with constant linear acceleration, CLA. And this time we're starting with an initial position. And with this initial position, we see that the slopes are gradually getting steeper and steeper as time goes on. So that means that the velocity of this graph is increasing. However, the velocity is also getting more and more negative. We'll draw our line like so. And again, we have a slope there, and the slope of that velocity time graph represents the position, or doesn't represent position, I'm sorry, it represents the acceleration. So here we start not at position 0, we start at some other one. So we'll draw a dot, and then these arrows increasing in size to denote acceleration. Number 6, we're starting at 0, and our slopes start bigger and then gradually get smaller and smaller and smaller. So this means that we're starting with some initial velocity, and then it's gradually decreasing. So we can draw that as a decreasing slope on the velocity time graph, yet still positive because the velocity there is still positive. So we're starting at the 0 point, but this time we're starting faster and then slowing down. Number 7 is just the reverse of number 6, where again we're still starting with a high velocity, but the slopes on this one are all negative, and they're all negative, but they're slowly, the slopes are slowly decreasing in size. And when that slope is smaller, that means that the velocity is less. So this graph will look about like so. And again, now we have, oh, I'm sorry about that. And actually, forget that, never mind. I don't know why I did that. This one does have a negative velocity, but that velocity is slowly becoming less and less negative as that slope changes. So here we're going to start with a positive position, so we'll call 0 right there. Start with a positive position, and those ones are going to be moving faster than the ones later on. And now number 8. Number 8, we get a true parabola here. Now with the true parabola, that means that we can really get this broken up into two different parts. The first half. Hello.
Is he coming back?
Yeah,
Okay.
he is.
Okay.
I'm just talking my iPad.
Oh, recording?
Yeah. So we see that we can break this up into two pieces. We have a dashed line there. On this first half, we have positive slopes that are slowly becoming less and less steep. So when it's becoming less steep, it's still positive, but not as much. So for the first half, we can draw a higher velocity heading towards 0. And then right at the peak of that parabola, it switches. So now these velocities are all negative because now all the slopes are negative. And at the top, they're less negative, and at the bottom, they're more negative. So we're just going to keep on drawing this line through. So then if we're going to draw the motion map of this, right, so we're starting at 0. And we have a higher velocity going to a slower velocity. And then at the turnaround point, we have a slower velocity, then moving towards a higher velocity. So now we'll move on to number 9. Number 9, again, we have a parabola. So this parabola, we'll split it down the middle. And then as we split it down the middle, again, we see that these velocities here at the top are more negative than they are here at the bottom. So we're going to draw that up until that velocity is 0, because when it starts to transition, that velocity stops for a split second. And then as it starts going up again, these values are still positive, but they're smaller than what they are towards the end. So we just draw a straight line through. And now this one, we're starting with some initial position. So if we call that our 0 point, so we're starting, we're moving, we are accelerating, but we are heading towards the origin with a constant linear acceleration. But these accelerations here, I should draw them more defined because we have a higher initial velocity than we do at the bottom of the parabola. And then it's going to switch and head back in a positive direction. Now number 10. This one we can break up into two pieces. This last little bit here is technically, there is a slope there. It's no longer a constant linear acceleration. It is very tough to see. So if we do this for constant linear acceleration in that first part, the slopes are increasing. Now the slopes are increasing. That also means that the velocity is increasing. And then we have a set numerical value for that constant linear velocity, so that it flattens out. Number 11, number 11, we have constant linear velocity for the first second, and we have constant linear velocity for the last second. So when we draw these out here, we have a positive slope, or we have a positive velocity, that's constant. So we have a constant velocity for a second, and then the values begin to decrease, that slope changes, and the values become closer to 0. So we're going to draw that in for the 4 seconds there for that middle part, and then it is at rest, so the velocity is 0. Number 12. Number 12, we again see 3 tough to distinguish parts. Both these 3 parts, you can sort of define where they're at. If you weren't able to, it is understandable because they're tough to read. So the first chunk there has a negative constant velocity for 2 seconds. So we can draw that in. And then we have, and did not draw that one in right. So we have a negative constant velocity there for 2 seconds. And then we have a negative acceleration. So these velocities then are becoming more and more negative for 2 seconds. So we can draw those in. And then we have another constant linear velocity, and that line is steeper. So the second part is steeper than the first part here, and that's why this first chunk has a lesser magnitude of velocity than the second part. Number 13. Number 13, we see that we kind of have a parabola, but what we have is constant velocity for the first second, constant velocity for the last second. So this first constant velocity here, the position isn't changing, so we're at 0 velocity. Then we begin to have constant linear acceleration for the next 3 seconds. So then we'll have a slopiness to that line, and it's positive. And then we have another constant linear velocity at the top. Now number 14. Number 14, for the first second, we have CLV. And then for the last 2 seconds, we have CLV. And so the first part of the graph, we have a positive velocity of 2. And because we're going up 2 over 1, up 2 over 1 there, so we have 2 for the velocity. And then we have still positive velocity, but the velocities are gradually making their way towards 0. So we can draw that in. And then the last bit, that slope, is about 1/2. So we have 1/2 for the constant linear velocity. And then number 15. Number 15 gets broken down into 5 pieces. We have linear velocity, acceleration, linear velocity, acceleration, and linear velocity. So this one, we have a slope of about 1.5, and it's positive. And then we have linear acceleration, that's going to bring us to our 0 velocity. And then we have linear acceleration again, and then a constant velocity to end it. And then number 16, we can break down into 4 different pieces. So for about the first second and a half here, we have linear velocity, or we have linear acceleration, I'm sorry. And then we head into another linear acceleration. And then we have a constant velocity, and then a linear acceleration. So as we draw these, I got to be fast about my time here. It's going to look like so. So that's the video. Hopefully it helped.